Okay, let's go ahead and get started with the notes for today. So, in our notes, we're going to learn about special right triangles. And when I talk about special right triangles, what I'm talking about is that they have special angle measures, which lead to special side lengths going on within them. So, there are two types of special right triangles. So the first one we're going to learn about is the 45-45-90 special right triangle. So the legs of a 45-45-90 triangle are always congruent, meaning that this is an isosceles right triangle. Now, we should have known, or should know, that when you have two angle degrees or angle measures that are the same, that you're also going to have the sides being the same that are across from it. So in order to make our lives easier, we're just going to choose those sides to be 1 and 1. And we're going to call this our base model. So we're going to decide all of the sides for our base model. Now, in order to go through and figure out what our hypotenuse is, we can actually use something we learned from last unit. Last unit, we learned about trig and the Pythagorean theorem. So which of those should we use here? Correct, we should use the Pythagorean theorem. So what we'll do is I'll write up in this corner the Pythagorean theorem for this one. So it's our hypotenuse squared, which is x squared equals our two legs squared. 1 squared plus 1 squared. Now be careful when you do this because 1 squared is correct. It's 1. So 1 plus 1. So x squared equals 2. Now we square root, and x equals the square root of 2. All right? And there is no simplifying of the square root of 2, so our final answer will be that our hypotenuse is the square root of 2. So this will go through and we'll label as our base model, okay? So base model is going to be whatever we put on top. So our base model for this one, so across from our 45 degrees, I'll box this one. So 45 degrees is across from 1. Our other 45 degrees is also across from 1. And our 90 degrees is across from, right there, the square root of 2. So what we're going to do here is we're going to use our base model to create proportions. Notice I put them on top of lines because we're going to do proportions. So you'll always be given a new one that you're going to try and find pieces of by using this base model. So all you need to do is remember 1, 1, and square root 2. All right? So when completing these problems, we can always compare our given triangle with the base model, which is what we just created, the 1, 1, and square root 2, and then use proportions to solve. This means we can cross multiply, which you guys were really good at. So cross multiply. All right? Now, one thing that we do need to note here is that when you cross multiply, we talked about this, I think unit 6 probably. When you're cross multiplying, you can only ever use 2 fractions. So use only 2 fractions. Oops. Okay, we'll just pretend I put it up there. 2 fractions at a time. Okay, so what that means is I'm going to have to set up 2 equations if I want to find all of these answers. Okay, so if I need to find all of the parts, I'm going to need to do it twice. All right, so what we have going on in these pictures is if you look at number 1, so what I would always do is I would find the missing angle. So it's 45, 45, and 90. All right, now I'm going to set up my base model. So I have 1, over 1 over, and the square root of 2 over. Okay, so remember the 1's are supposed to be over whatever's across from my 45-degree angle. So I have x, I have 8, and then my square root of 2 is across from my 90-degree, which is going to be y. So notice we're actually going to have to set up two fractions. So for example, this one, I need one with a variable and one with all numbers. So I'm going to do 1 over x equals 1 over 8. And then I'm going to do the same sort of thing. I need one with variables and one with all numbers. 1 over 8 equals the square root of 2 over y. And now I'm just going to solve them by cross multiplying. So cross here, 1 times x is x. 1 times 8 is 8. So this one was an easy one, and x equals 8. Now I'm going to do the same thing for my orange one. So crisscross. 1 times y is y. Now this is where we need to remember stuff from our warm-up. So we have 8 times the square root of 2. One is on the outside and one is on the inside of the radical, so you do not combine them, so it's 8 square root 2. So y equals 8 square root 2. Okay, now we're going to do the same thing in the next one. So I'm going to label with my other 45-degree angle. Perfect. I'm going to write my base model, 1 over square root of 2 over. My 1's are across from my 45. Y. That one is 25. And then across from my 90 is x. Now I'm going to use the same exact process. So 1 with variables, 1 with all numbers. 1 over y equals 1 over 25. Again, variables, numbers, 1 over 25 equals the square root of 2 over x. And I'm going to cross multiply just as I did in the previous problem. So 1 times y is y. 1 times 25 is 25. So y equals 25. Now I'm going to do the same thing here. Just cross. 1 times x is x. 25 times radical 2. Again, don't go together, so 25 radical 2. And that's all. Wonderful. Everything is the same so far. Now let's check for the next one. So again, fill in the 45-degree angle. Now I'm going to let you do it. So base model. So my base model is good. 1, 1, radical 2. Great. Now across from my 45. Across from my 45. Y. X. From my 90. 19. So same sort of thing. I'm going to go through 1 with variables, 1 with all numbers, 1 over y equals the square root of 2 over 19. And then I'm going to do the same exact thing. 1 with variables, 1 with numbers, 1 over x equals square root of 2 over 19. Now if you notice, our two setups are exactly the same. One has an x and one has a y. So once I find one of them, I'm going to go through and it's going to be exactly the same for the other one. So since I have more room over here as my x, that's what I'm going to do. So cross multiply. Now, usually it's been 1 times x, but this time it's the square root of 2 times x. So I'll write it that way. The square root of 2 times x equals 1 times 19. Now, we need the square root of 2 to leave us, so we're going to divide by the square root of 2, divide by the square root of 2. Now what we need to remember is what we did on our warm-up. So our warm-up, if we had something in the bottom that was a radical, you multiply by exactly that number on the top and on the bottom. So the square root of 2 and the square root of 2. Now I'm going to bring this down. So I have 19 square root of 2 over, what is the square root of 2 times the square root of 2? Good, it's the square root of 4. Now our goal is to make sure that radical is no longer in the bottom. So that means that the square root of 4 must simplify. So we have 19 square root 2. The square root of 4 is 2. So we found x, and because x and y are exactly the same, because our setup was the same, that means that y is also 19 square root 2 over 2. Okay? And that's just as hard as it gets. It does not get any harder than that. Okay? So now we need to do base model number 2. So our second type of special right triangle is a 30, 60, 90 triangle. So 30, 60, 90, it says the shorter leg is always opposite the 30-degree angle, and the longer leg is always opposite the 60-degree angle, which we should know. So what I'm going to do to help us create what numbers go there is I'm actually going to turn this triangle, this right triangle, into an equilateral triangle. How I'm going to do that is I'm going to take this triangle right here and I'm going to flip it. So I have this triangle here. Okay? So this is exactly the same triangle, so this one is also 30 degrees, and this one is 60 degrees. Now, I'm going to pick the number 2 as our side length in order to help us. This is going to create our base triangle. So 2 is just an arbitrary choice that I've made. I chose it to be even on purpose, and you'll see why. So if this is 2, this one is also 2. Now, that means that this length from here to here is 2 as well. However, it's been split into 2 pieces. So how much is each piece? Correct. It's 1. Because 1 plus 1 is 2. So now you'll notice in our right triangle that we were actually given, we've gotten 2 side lengths. So I'm going to get rid of this. It was used just as a helper so you could see where these numbers come from. And we're going to find the third side. So the third side, we're going to put an x here. And we're going to do the Pythagorean theorem again. Okay? So I'm going to write it down, but I'm going to have to erase it afterwards. So what I'm going to do is I'm going to write it. And then if I can, well, I might be able to keep it. Let's see. So we're going to do the Pythagorean theorem. That would say 2 squared equals x squared plus 1 squared. So 4 equals x squared plus 1. Subtract 1. 3 equals x squared. Square root, x equals the square root of 3. Okay, so now we can replace it, and we've got our base model. So over here, I'm going to write base model. I should be able to keep it, so I will. Base model. Okay, now this time we don't have 45 and 45 being exactly the same. We instead have a 30-degree angle. We have a 60-degree angle. Now we have a 90-degree angle. Okay, so across from my 30 is the smallest number, which is 1. Across from my 60-degree angle is my middle size number, which is the square root of 3. Alright, and across from my biggest angle is the biggest number, which is 2. Now, one way that might help you to remember which one is the smallest number, which one is the biggest, is that the square root of 3 is smaller than 2 because 2 is the square root of 4. The square root of 4 is technically right here as my biggest one, the square root of 3, and then you could even think of this one as the square root of 1. Now we're going to use all of this to help us find things. So this will be x, y, and z. Alright, so it's all about locating our base model. So let's do that here. So locating our base model. Alright, so what we have here is we need to find the other degree measure that's missing. That's our 30. And now we'll create our base model. So our base model goes 1, 2, 3, and 2. Now we're just going to match them up. So 1 is the smallest, so across from the smallest is y. Now across from our medium is x. And then across from our big will be 6. Now we're going to do the same exact thing. So variable, all numbers, and put it together. So we have 1, whoa. We have 1 over y equals 2 over 46. And then we're going to do the same exact thing. So variables, numbers, square root of 3 over x equals 2 over 46. Now it is possible if you want to simplify 2 over 46 you could, but we don't have to. It's not necessary. So we're going to cross multiply. That gets me 2y equals 46. Divide by 2 and we get y equals 23. Now we're going to do the same thing here. Cross multiply. 2x equals, now remember, same rules apply as before. Square root of 3 is inside of a radical, so it does not get combined. 46 radical 3. Then I'm going to divide by 2. X equals, now 2 and square root 3 don't touch each other at all, but these two are on the outside, so we'll do 23 square root 3. Wonderful. Okay. Now the process remains exactly the same. So it's going to go 1 over square root 3 over 2 over. Now we need to look at which one's missing. It's the 60-degree angle, so we'll fill that in. So across from the smallest, 14. Across from the middle one is y. And across from the big one is x. So again, we're going to set up two equations. Numbers, variables. 1 over 14 equals square root 3 over y. And then same thing. Numbers, variables. 1 over 14 equals 2 over x. And now we'll cross multiply again. So cross multiply, cross cross. Y equals, these don't mix, 14 square root 3. And then we'll cross cross. X equals 28. Fantastic. Alright, now we're going to do the same thing here. So we're missing 60. So base model, 1 over square root of 3 over 2 over. Alright, across from the small is x. Across from the middle is y. And across from the big is 32. Okay, so again, variables with numbers. 1 over x equals 2 over 32. Variables and numbers. Notice that your one that has numbers, all entirely, the fraction with entirely numbers gets used twice every single time. Okay? And then we have the square root of 3 over y equals 2 over 32. Now we're going to crisscross. 2x equals 32. Divide by 2. X equals 16. Alright. Now the next one we're going to crisscross again. 2y equals, remember they don't go together, so 32 radical 3. Okay, now divide by 2. Now remember dividing by 2 only affects the outside number, so 16 square root of 3. Wonderful. Great job, guys. Now, the backside has a bunch of example problems, but I'm actually going to go through and just show you maybe one of the hardest ones, okay? So, all of these should be very simple, but I figured it might possibly be a little bit harder in number like 19, 20, 21, 22. So I'm just going to pick 2 of those to do. I think this one looks scary, so we'll do 22, and maybe we'll do 19 as well. Okay? So the place that I know where to start is I'm going to look and see which one has a number as a side length. So I'm going to highlight this one. And I'm going to start here. Okay? So in that one, I'm going to start there. So one thing I know is this is 60. And I have a 30, 60, 90. So I need to use my base model for a 30, 60, 90. That's 1. Square root 3. 2. Alright. So across from my smallest is 9. Across from my middle one is nothing, but since that's where they connect, I have a feeling I might need to find it. So I'm going to call it, we use X, Y, and Z, we'll call it W. Because I have a feeling I'm going to need to use it. Alright, and across from my biggest is Z. Now this is exactly like we've been doing every single other one. So, all the numbers with the variables, 1 over 9 equals square root of 3 over W, crisscross, W equals 9 radical 3. Now, I didn't ask for W, but I just have a feeling I'm going to need to know it. So this is 9 radical 3. And we'll deal with that as soon as we need to get into our 45, 45, 90 triangle. Now, I'm going to go through and I'm going to find Z. Numbers as well. So 1 over 9 equals 2 over Z. Z equals 18. Great. Now we still need to find X and Y, so what I'm going to do is, one thing that I noticed is right here, this one is 45. So we have our 45, 45, 90 triangle, so we need to go back to our base model of 1, 1, square root 2. And this is going to be something that you have to memorize. The only way to do these problems is if you know your base model. Okay? So 1, 1, square root 2. So across from my 1 is my smallest one of X. And then same thing here, so that's Y. And then across from square root 2 is 9 square root 3. Oops. So, because these are going to measure the same X and Y, since it's isosceles, I'll just do one pair. Okay, so let's just do this one. Okay? So we have, this one's going to be kind of hard to fit here, but it's okay. So we have 1 over y equals square root of 2 over 9 radical 3. We're still going to crisscross. So we get the square root of 2y equals 9 radical 3. Gross. We have a lot of radicals here. But it's the same process. So divide by the square root of 2. Divide by the square root of 2. Now we've got a problem because we can't do 3 divided by 2 even though they're both inside. They don't simplify. So we have to multiply by what's on the bottom. So the square root of 2 and the square root of 2. Now what we have here is that these are both on the inside. So 3 times 2 is 6. And then we have 2 times 2 is 4. I'm going to bring it down here so it doesn't get in the way of z. Then we have 9 square root 6. What is the square root of 4? It's 2. So because 6 is inside of a radical, it cannot simplify with 2 because it's not inside of a radical. So that is your final answer. 9 square root 6 all over 2. And this one is exactly the same because it's a 45, 45, 90 triangle. And it's isosceles. So that one got a little bit gross, but that's probably one of the hardest ones you could ever see. Okay? Now since that took a while, I'm going to skip doing number 22, but I'll have this answer key up on Google Classroom. Alright, good job.